Hello, I'm Angie Moon. Nice to meet you.
Thanks for coming.
Yeah, I am a maintainer of simulation-based calibration package as part of STEM development team and a pre-doc at MIT Sloan.
Turn down the volume on this, please. I was hearing it, even though it's muted in the mic.
Yeah, so I will today introduce simulation-based calibration, which I believe is the core of Bayesian workflow. And in the end, I'm trying to persuade you that we need this actionable Bayesian workflow in order to reverse engineer the Bayesian models based on the simulated base, the spirit. First, to illustrate the role of SBC in Bayesian modeling, I'll first start with what I really love, classic music. Did you know that we can have free tickets to Bayesian? Sorry, no free tickets to Bayesian, Boston Symphony Orchestra. So I've been going there and wondering, what is the role of this conductor doing? He or she, or is just bowing? It was much after I realized that he is orchestrating, which means that he is attributing or directing elements of a situation for the desired effect. So what is the conductor actually orchestrating? They are the spatial and temporal members. And during the rehearsal, he is practicing thousands of times with each member in order to produce the final moment that he is showing. As you can see, like this is the score that he is viewing, and there is both t-axis and all the different members. So I'll come back to the Bayesian workflow story. And this was, how many have you actually heard about the Bayesian workflow? Okay, thank you. So this is the framework that was proposed by Andrew Gelman et al. At 2020 to improve efficiency, reliability, and reproducibility. It is an iterative process and a learning and development and experimentation. Iteration is the key, but there is no optimal trajectory for this. So this is in active development, and every year it's been changing. SBC is classified under validation of computation in that green box. But I believe its spirit is based on a Bayesian time machine that assumes joint distribution of observed and unobserved, so that we can switch the cause and effect. We can experiment this with our Bayesian time machine. And all of these three equations delivers the spirit quite well. And SBC, which is a 2018 paper by Heltz, uses the last equation in order to make a tool, a procedure tool to check this consistency that should be maintained between the computation and statistical model and the prior knowledge we have. So what it's doing is it samples from the prior and it generates the outcome Y, and then it also generates, or we sometimes call it inferring, different posteriors from each data sets. And in the end, what we are saying is the aggregated posterior should be the same with the prior. They should be indistinguishable. So that's the basic spirit. I know this may be confusing for those. It took me more than 1 year to fully understand this, so I drew the diagram. So if you follow the numbers in the diagram, we start from number 1, the samples of the prior, and then we move on to samples of the outcomes. And then we infer the samples of the posteriors. And number 4 is the main contribution of 2018 paper. So we compare different functions of theta and y to create one rank statistics for one data set. And the assumption is, if everything is in harmony, if it is orchestrated very well, it should be uniform. The rank should be uniform. Any deviation from uniformity gives us some clue, visual cue, to improve during the rehearsal. One way to implement this in Bayesian setting, or in STEM at least, I've been seeing most of the examples in STEM, which may be limited, is first you sample from the prior distribution that users have in mind. And then you sample the Y's from the data model. And then with the instead, most of our use HMC algorithm, so we know that is correct. So at least asymptotically unbiased. And then we sample m numbers of posteriors from each data set, and then we compare that. So yeah, this is the diagram for that. And you may wonder what visual cues we may learn from that. And these 4 cases are usually what it gives. So if the ranks are very underdispersed, we call that smiley faces. It means that we need to widen the prior for the measurement error in most cases. But I know, as I said, like if there is some non-harmonious thing happening in our orchestra, we have to track down the errors. We have to see, compare, and all those sort of things. So what I written here as possible remedies are majority of errors comes from that. It does not cover every use cases, but many people usually wrongly or their bug in their model is usually the measurement error that I've seen.
Just a question. This is it's very interesting. Do you know if the STAN community has tried to do a systematic evaluation of these claims qualitatively? You know, right, for example, can imagine synthetic experiments, which check the degree to which, you know, the remedies fix the problem, where you take a model and you introduce a bug, and then you try to fix it.
So you mean like automatic update of your model based on this diagnostic?
But not as a user-facing feature, merely as a methodology for just sort of trying to study this mental model for how the orchestra goes wrong.
Oh. No, I haven't seen it, but that would be very interesting.
One point I'll make is that there are, in that vector from the current practice of SBC, you know, there's probably a lot of opportunity for academic software engineering research that does various things along that, you know, kind of in that.
Yes.
In that
I
spectrum.
see what you're saying. So one possible way to do that is, in the end, we have some key values, or like at least we're doing some type test to test how we are off from the uniformity. And if we somehow use that as an objective function and calculate the gradient, maybe we can update some model. But yeah, thank you for helpful.
Yeah, I'm curious. So these possible remedies are things like changing the measurement error in the model. And naively, it seems like the measurement error that you put in your model is right or wrong based on what happens in the world, right? Are my measurements actually that noisy, or are they not that noisy? But the SBC procedure doesn't have to do with your actual data set. It's just something about, it seems like, whether HMC is good at dealing with this model. So what are the implications of making your modeling choices, you know, here, based on SBC?
I see.
Yeah.
So there are many different moving parts in here. So my conclusion, or what I'm trying to suggest later this talk, is try to fix one of the components and change the other, and on the other hand, change the one thing and change the other, so that you can actually detect where the problem comes from. And that might be possible because there are finite numbers of components out there, which I will introduce.
But it sounds like if you were assuming that HMC was implemented correctly by STAN, then one possible remedy for all of these is just run longer. Is that right? Or am I misunderstanding?
I didn't catch
Like you were, it sounded like you were saying, if we assume for the moment that
Stan's implementation of HMC is valid asymptotically. So then is one possible remedy for all of these cases, just run longer?
Oh, yeah, that is a good question. So currently, the dynamic is not included in the SPC. So there are many limitations. We have stated that in the package vignette, and you can see for that, but I believe that the run longer is one area of dynamic. So even though we checked the convergence diagnosis of the MCMC, this is my computer, right?
The Slack thing is mine, that because of the Zoom, I apologize.
Okay. Yeah, but where to start or end that, where to start this actual sampling, we just assume that everything is perfect for now. Did that answer your question?
Assume that it's for, but like like the right hand side is from actually running Stan, like high cost.
This
running
part is
Stan.
where the pen is coming in. And this is where usually we check the computation. But we assume that HMC, if it is in the area of typical sets, it returns a perfect or unbiased posterior samples.
But if that's the case, why would this ever not be uniform?
That I will introduce soon.
Okay.
I mean, so it seems like the answer is that you're sort of tuning the model instead of inference, right? In this sort of
But
process,
for
like,
any model, if inference is correct, then it still be low. And like that
Yes,
was point, you shouldn't
right.
change the model, like any of those changes should still be good.
right, so I guess you fix some parameters in HMC and then look at these plots and then change. It's interesting. Not sure.
Okay, I hope the upcoming slide would help the confusion. So until here, I'm trying to say that simulation-based calibration is orchestrating during the reversal. But you may wonder, so what are the members to orchestrate? That was the question that you had just now. And so I can think of many different things. We have statistical model and we have computational model. And also we have some unobserved parameters. And also we have some observed data outcome. What is usually left out in those statistical model is this, what we call policy levers. So this is why I changed my major, why I came to MIT Sloan from operational research field, is because I wanted to build a model that is very practical so that this statistical model building and computation can affect the society in synchronized together. I will come back to that soon. So for unified Bayesian taxonomy, I'll define three things. First is joint distribution of your parameter and observation, P, theta, and Y. And second is approximator. The example would be HMC or variation inference or something like that. Each domain expertise will know its components very well, but as a conductor, we just need to couple or coordinate or orchestrate each component. So that is why black box the subsystems beneath it. And the last component is observed data. The next step is to orchestrate or couple PADs. So we can think of three things: PA and PAD and PD. However, we usually address the first two because PD is ideal form. That is the perfect posterior. So if you really run HMC for a long time, as you can see from here, this is millions and zillions of samples that is very smooth. And that is what this PA or PAD is trying to be closer to, approximate. So I will now introduce SPC use cases that I've seen so far. We say they are largely two use cases. First, debug your model implementation. This is most of what Stan community is using for. It is testing your statistical and computational model, whether they are coordinated well each other. And the second is, I think what you would be more interested in is proving that your inference algorithm is correct for many P's. So I heard that you are designing, I'm sorry if I'm wrong, designing some customized kernels during the sampling. So in standard community, that happens very under the hood. So you usually have to know C++ coding for that to do something customizable. So most of the cases I've seen is the first case, but second case can be used as SBC as well, because in the end, SBC tests how everything is harmonized, and it flags whether something is wrong, but you don't know actually what is wrong. Third one is, may I ask your name? Cameron. Yeah, third one is what Cameron has suggested. I think it addresses a similar thing. In SBC theory, we assume everything is perfect. So for instance, we say that we run HMC for a very long time so that it approximates P, the smooth perfect posterior perfectly. But in reality, due to the limitation of resources, that's not actually the case. We cannot sample 1,000 priors in our first procedure. We have to somehow trade off based on our limitations. So we have to decide how to tune that hyperparameter, or some people call as nuts and bolts. And in the end, this is my conclusion, but we can choose this SBC testing approximator based on the P joint distribution that I have in mind that we will practice. Yes.
So 2 and 3 make a lot of sense to me. I'm wondering if you can say a little bit more about what kinds of bugs
Thank you
a
very
model
much.
might have that you could catch with SBC.
May I ask your name?
Alex.
Alex. Thank you, Alex. I prepared the next slide for you. Yeah. So this user is using different algorithms, like not only Stan, he uses also Bob, for instance. And he wrongly assumed that Stan parameterized the normal distribution is by variance, not as sigma or standard deviation. So the first example is when that mistake, when he wrongly assumed that Stan parameterized this. So he used a model and he coded in Stan. You have to do 2 codings when you're doing the SBC. You have your generator, and you have to do your Stan coding at the same time. Does that make sense? Understanding this is.
So you're not actually generating from the model density. You're generating from the generated quantities block, or the RNG code, which uses a different normal distribution that.
Not exactly. So when you're generating from normal, like mu and sigma squared, right? And the first 2 steps of previously. So the generator is correct, but when you are designing your approximator, which in other words, writing your Stan file code, you have wrongly encoded that you mistakenly put sigma squared instead of sigma. So your approximator is incorrect, is not in sync with your generator.
Your density code
Yes.
that HMC uses is not actually
Yeah.
the same as the model that's being
Yes.
generated from.
Yes.
Yeah.
So the optimization algorithm went off.
Yeah.
Right? Mhm.
So just want to ask a question, and if this isn't clear, or you don't know the answer, we could talk about it some other time, but has the Stan community explored automating generators for restricted class of Stan programs where that's possible?
I'm sorry, I'm not the best person to know that, but I know that there are like community for Julia, and I know that you do gen for that. But I don't.
Not for Stan, okay, yeah, it's to the best of your
Not
knowledge,
as-
nobody
yes.
in Stan is sort of trying to automate
Mhm.
for generation, because you could. Okay.
Sorry. I wasn't sure. I'm trying this using iPhone to remote control this for the first time, but there is no backward. So I only go forward.
The metaphor.
I was gonna say you're conducting an orchestra.
Yeah.
Yeah, in orchestra, you can't go backward. So this is, yeah, the rest of the presentation is my proposal, or like based on my research on COVID dynamics, what this SPC or simulation-based calibration should look like in the future. So I think it should be very dynamic. For instance, as you can see the graph, we don't need to look until the end. For instance, this 1000 was, if you have a very great memory, it was S in the previous slide. Sorry, I cannot go back. And S is the number of prior samples you sample from the prior distribution. We usually recommend 1000 or over for that. However, we do not need to fit 1000 different data sets to know that something is wrong. We can detect that early on using some gamma threshold statistics that we've developed, so we can early stop it. That is one proposal. And as I mentioned, I will come back. I really believe that some actionable or policy level parameters should be included. So this is the a little bit complicated version of SIR model that incorporates the people's behavioral of some policies. And I color coded different parameters. They all call parameters, but once I moved to this low school, the instead community, I only dealt with models that have at least 3 or 4 parameters, and we really chisel all of that very delicately. But once I come here, there are like 300 parameters coming in. So how can I give prior distribution for all that, and how I can estimate and calibrate all that? So I think that is why the automation that Because is that your first name?
Yes.
Okay. Has commented. So general idea is the first green one is disease character. So for instance, cause, sensitivity, or seasonal amplitude, or initial infection rate. And the second blue one is the community character, initial population or context stratification, or available hospital beds per capita. And the last one is what I really want to emphasize, because that would be the most interest of the stakeholders. So group isolation or state policy switch or fatigue threshold or behavior change or threshold or sensitivity or response time. So in the end, I believe that calibration should be based on the simulation-based period that I've suggested before, switching cause and effect, in order to determine this policy level in one model. So this may be one very drafty way of doing this, but at least I believe that there should be some parallel flows of one flow building this model and calibrating the 3 components, PAP, in real time. And also the other flow should determine this design policy and test policy deterministically, because policy itself can change based on which time you're in. So this model itself should be very dynamically changed. And this is one architecture that has been used for the past 3 years. So perhaps this can give the idea of how the data team and model team collaborate to build this dynamically changing COVID models and its policies.
Oh, sorry, on the previous slide,
Sorry.
yeah, never mind. I can still ask the question, which is, so I didn't, it would help me to get a sense of how the model outputs were used operationally. I couldn't tell from that figure.
So that figure didn't convey that. It was after 2 years that we have used that model that we reached to the conclusion that policy should be estimated and they should be encoded in the model as the parameter. Do you somehow agree that policy levels are unobserved parameters?
Well, I think it's it's interesting. I think one could try to encode them in the model.
Mhm.
I sort of maybe personally think of sort of a tower of probabilistic computations for state estimation and then decision making and then feedback.
Mhm, yeah,
I don't know how you're flattening that in what you're saying, but yeah, maybe the spirit of it, I think so.
so I think it cannot be flattened in one
Yeah.
figure. But one example is, stock management situation.
Yeah.
So there we can estimate what is the optimal level of inventory that you should rebuild to in every period of time. So those policy levels or those optimal parameters can be, I believe, encoded in the model.
Yeah, I see. So you're just making a model that's conditional on certain
Yes.
parameters of the operating.
Yes, that is.
Yeah, conceptually that makes sense, but I want to just try once more to ask which is, because it sounds like this project grew out of, the hope of really informing
Mhm.
COVID response in the world.
Mhm.
So I'm just trying to get a sense of where down that road did your collaborators get? So I saw data from a COVID tracker
Mhm.
coming into the model.
Mhm.
And I'm just wondering, was the model that you showed developed with customers for the model's output? Like by analogy, the Ferguson team at Imperial that did, stand-based analyses and, non-pharmaceutical interventions across the EU
Mhm.
in the early days of the pandemic,
Mhm.
right? Their customers were a set of policy conversations.
Mhm.
I think my understanding is they're mostly happening in the UK.
Mhm.
And that kind of guided how they designed the stand model, because they knew they were going to have to persuade a particular set of policy stakeholders in a
Mhm.
certain kind of meeting.
Mhm.
So a lot of the details of like what they even chose to model or not
Mhm.
had to do with working backwards from those conversations as
Mhm.
much as working forwards from first principles and statistical methodology. So I'm wondering, how were those forces informing the design of your model, those kinds of forces?
I think there's a very important question. So back in Stan, when I was in Stan community only, I believe that it's for flow. Flow comes a lot today, but data, draws, and decision. So we have this data and we have the prior knowledge, and we add some computation to it, and we get the draws of the criteria. Then we do some decisions. However, I thought it should be starting from the decision. So we should say what decisions can our model produce? And based on that, what is the data that we should seek for to make this decision robustified or like robust? Like what data may change this decision or something like that. So it should be backwards. So that is why I like where I am at management school, because there are many, I can have conversations with decision makers and I can somehow reverse engineer the STEM models or something like that. But that's a very perceptive comment. Thank you. So this is the last slide. So my advisor says he has a feel when our model is capturing the dynamics. Somehow our model is correct. It's capturing the dynamics, it's saying that. And I believe the most important feature of SPC is to really know when to let it go. You cannot build your model forever. So like, this is my favorite conductor, Karajan. And he said, the art of conducting consists in knowing when to stop conducting to let the orchestra play. So I think that spirit, to let it play, is the concept that I wish to deliver. Thank you. Can I leave the meeting?
Yes, you totally can. Say it's about 3:30, but probably do a couple minutes of questions.
Yeah,
before we-
let's do a few minutes. Is that okay?
Yeah,
that's fine.
Yeah, thanks very much. That's exciting to see this whole direction of work. If you can say a little bit about types of feedback, that would be especially helpful from us, or anything like that. We'll obviously, we have plenty of questions, but I think we can come at this from lots of different angles. And it would be helpful even to know, yeah, anything, if anything comes, given what you have seen about ProbConf, is there anything that comes to mind for you that you'd like input on?
Am I correct that you would be most interested in the second use case of proving that your inference algorithm is correct?
Even for SBC?
Yes.
I mean, I think. I actually think we're interested in tooling that helps probabilistic programmers all through the workflow.
Mhm,
And that includes model criticism
mhm,
and sensitivity analysis, like Joao on Zoom and I were chatting about
mhm.
estimating gradients of marginal likelihoods of data with respect to hyperparameters that
Mhm.
were
Yes.
like policies
Yes.
this weekend. So sort of very, and like what are Monte Carlo estimators that combine SMC and HMC might be useful for that. So we're very interested in, I think we're actually interested in all of these cases.
Mm.
And your setting is super interesting. So that's partly why I wanted to understand,
What do
more,
you mean by setting? Which part of the setting?
this COVID model that you're using to
Oh.
test out the ideas
Mhm.
and sort of the, because it's. I very much resonate with the idea that you'll get a very different view on what's important in computational statistics in a management department
Yes.
than you will in a statistics department.
Yes.
So we get to, but I don't want to, if people have questions, you should ask it. I just wanted to give you the chance to ask us if there are specific things you knew, might be interesting for us to comment on.
No, I just came here to.
Okay.
Explain and introduce. So,
Yeah, so
may I ask your name?
McCoy, I think we met
Oh,
previously.
hi.
Yeah. Yeah, good to see you. Yeah, this talk was very interesting.
Mhm.
One element of SBC, which is somewhat confused me in the past, is there are certain hyperparameters of the SBC test that you sort of have to determine
Yes.
in a somewhat ad hoc way. For
Uh-huh.
example, I think in the original Talk et al. Paper, they
Mhm.
actually suggest that if you have a large number of posterior samples, you downsample to a specified number per bin and look at like less, histogram bins
Mhm.
before you formulate like your inverse CDF test, right? If you're doing some, and you can choose, of course, how you're
Yes.
testing the test statistic. These choices to me always seemed somewhat ambiguous, and I
Yes.
wondered if you have any comments about, your
Mhm.
philosophy on choosing these things when you're using SBC to make decisions about, model goodness of fit or something like that.
Yes,
Um,
that's a very good question. So the third use case of the previous slide was hyperparameter tuning.
Yeah.
So that is what I view as hyperparameter. So
Right.
if you go to the R10 ARM SBC, users encode this A and B of the hyperparameter. So even though we are simulating from a Bayesian model, we cannot go forever, right? In the end, there would be some numbers on it. But I think one spirit is we want to make that as less affecting the full model as possible. So testing that will be very useful.
Have you encountered interesting cases where SBC passed, but you were sure it wasn't working well? So like, for example, if you, instead of doing inference at all, if you just sample from the prior, SBC
Yeah,
will pass. But are there cases that you've encountered in the wild where it looked like SBC was giving you a thumbs up, but it wasn't actually working well? Like the inference itself wasn't looking good?
So from a modeler's case, SBC, we just say if we pass it, we're good. So I don't do afterwards. I don't think about it. But as a SBC designer, I'm aware of those cases. And the upcoming paper that I'm co-authoring is trying to hierarchize different tests. So SBC test passing and this perfect posterior. And also what's called data average posterior. They have some counterexamples of the last two. So this posterior passes SBC, but it doesn't pass the data average posterior test. And there's another thing as well. So we will try to spell out the specifics for it. Thanks for the question.
So when you were introducing the setup, which you did really nicely, it just struck me the jump from, and this is true of SBC in general, like the jump from there are these two distributions that should be the same to the particular form of test that SBC uses, the rank test. And I was wondering if you were aware of, or maybe other people in the room have seen, like general like classifier based where you just take a bunch of thetas from the prior and you take a bunch of thetas from the posterior and you see if you can train a classifier and tell them apart. Or even if you can train a classifier to look at a Y
Mhm.
and two thetas and tell which one is the real one and which one is the fake one or something.
Yes.
Like, it seems like if you ever can get better than 50% accuracy,
Yes, yes.
something must be wrong with your algorithm. Is that something that like do you know if that's something that's been explored or more generally, if there are other tests that have been looked at for?
Thanks for the question, Alex. So that's why I've been feeling that SVC and generative adversary network somehow share a spirit. Because here we give the result of 0 or 1, pass or fail. And using that output, somehow we can drive the prior or something that is wrong to improve that. But it took me like one year and I'm doing that. So perhaps tune in. Yeah,
Awesome.
thanks. Yeah. Oh, by the way, Cameron, regarding your question, I seen one paper that uses not after convergence samples, but only using the before pre-asymptotic samples and determining whether there is wrong or correct. Because what they are arguing, I'm not an expert for that, but they're saying we are using the same kernels. So why should we wait until it converges to judge this bug in the kernel? Yes, so there is a paper for that. I can share with you.
Cool, yeah, thank you. One possible answer to your question, when Arthur Gretton stopped by, for us in my poster, for SRS a few years ago at ASF, he mentioned some MMT based goodness the test that he'd been doing. And kind of noticing how, like, you could actually, he was surprised by like just how discerning some of them could be of like neural net things that end up like not bettering the real world, but like could hone in on those artifacts very quickly. I can point to that paper.
One thing that's nice about your formulation of it, and I don't know if this is something you've been looking at as a research question, is you can at least ask as you increase the computational power of the classifier, how do you approach the limits from computability on, either on the one hand telling two distributions apart, or on the other hand checking if inference is accurate, basically. It'd be interesting to think through that carefully.
Yeah, and also like, if
And-
there
and
are
in
systematic
practice,
differences.
Use neural nets to.
Right,
To try to actually make better tests, because that actually seems like a pretty safe use.
Yeah, right. It's just a test that.
Yeah.
If it works, it works, and you know something is wrong. If it doesn't,
Exactly.
don't
And you
know
can
that
keep
something's
pouring
wrong.
computation
Yeah,
to keep trying to get more,
right, and I'd be curious, Cameron, like what kinds of discrepancies you could have between the two distributions that are fake or don't matter in practice, but a neural net can pick up on, because it seems like any discrepancy should be telling you something about your inference method not working.
Yeah, well, it depends on what you're doing with it, right? Like it might be discerning in a way that's not relevant for your application.
But does that mean the inference algorithm is wrong in a way that's not relevant for your application?
Yeah.
I see.
Which is the case for like for tons of different algorithms we are happy with in practice.
okay, well, thank you very much, Andy. This was really wonderful. We just need
One
to,
comments, sorry. So the upcoming paper's title is Good Choice of Test Quantities Can sensitively detect the bug in your SBC. So what we're trying to do is there are classes of test functions that can differentiate the perfect posterior versus what we have. And designing that is also another test. So I think that's where adversary.
Yeah.
Thank you. Thank you again.
Thank you.